Okay, I have problem number 2, and given this equation, I was supposed to solve for the relative extrema for part 1, and for part 2, I was supposed to find the absolute extrema on this interval. So given this value, I was able to determine the derivative by using the product rule. So I used the product rule, which is the derivative of e to the 2x times ln of x minus 1 plus e to the 2x times the derivative of ln of x minus 1. So given that, we can plug that in and simplify. So the derivative of e to the 2x is 2e to the 2x because you take the 2 and multiply it by e's coefficient, which is represented by 1. So you get 2e to the 2x times ln of x minus 1 plus e to the 2x times this derivative, and the derivative of ln of x is 1 over x, and the derivative of negative 1 is 0, so you don't include it in the final equation. In order to obtain the critical numbers, you set the derivative value to 0 and use solver to find both critical numbers, and you know that there's only 2 critical numbers because you can graph the derivative and see that it only crosses the x-axis twice. So the critical numbers that I obtained were 0.187 and the critical numbers that I obtained were x is equal to about the critical numbers were x is equal to 0.187 and x is equal to 2.156. Then you create a sign chart of f prime, plugging in both critical values along with values both greater and lower than that. And so for 0.1 you get a positive value, 0.187 is 0, and 2 is a negative value. So you can determine that that would be, or the 0.187 would be the relative max, and for this, going from negative to positive would determine that the 2.156 is the relative minimum, and then you get these values for your relative max and minimum because you can plug in both x values into the original equation to get the y values, and then that is your relative max and that is your relative minimum. For part B, we had to do the same thing except for we had to find the absolute maximum and minimum of the equation on this specific interval, and thankfully our critical numbers from earlier are in the same interval as given, so we don't have to change them and they're the same. So we put that into a chart with the endpoints of the intervals and both critical numbers, and we plug the x values into the f of x equation and get these values, and the largest value, the largest y value represents the absolute maximum, and the smallest f of x value would be the absolute minimum, giving us this result for our absolute maximum and absolute minimum.